Welcome to another episode of AI Talks with Chris and Nita.
It's great to be back.
You ready to dive deep into the world of ensemble learning?
Absolutely. I'm always up for exploring the fascinating world of AI and machine learning.
Me too. So today we're tackling ensemble learning, which is this really cool concept where we combine multiple models to get better performance than we would with just one model.
Yeah, it's like assembling a dream team of AI experts, each with their own unique strengths and perspectives.
Exactly. And two of the most popular techniques for ensemble learning are bagging and boosting. Have you heard of these before?
Oh yeah, bagging and boosting are like the dynamic duo of ensemble learning. They both aim to improve prediction accuracy and reduce variance, especially when we're working with those sometimes finicky decision tree algorithms.
Okay, so let's break these down one by one. First up, bagging. What does it even stand for?
Bagging is short for bootstrap aggregating. It's a bit of a mouthful.
Bootstrap aggregating. Okay, so how does that actually work in practice?
Well, imagine you have a big data set that you want to use to train your model. Instead of using the entire data set at once, you create multiple smaller subsets by randomly sampling from the original data.
Oh, so you're kind of like creating these mini training sets, each with a slightly different mix of data points.
Exactly. And here's the kicker. You allow for repetition in these subsets. So some data points might appear multiple times in a single subset, while others might be left out.
Interesting. So it's not just dividing the data into neat little chunks. It's more like grabbing handfuls of data points at random and seeing what patterns emerge.
Precisely. And then you train a separate model on each of these bootstrap subsets.
So it's like having a bunch of different students, each studying the same material, but from slightly different textbooks or perspectives.
That's a great analogy. And then just like those students might come together to compare notes and share what they've learned, bagging combines the predictions of all these individual models through a process called aggregation.
So instead of just relying on one student's answer, you get a more well-rounded understanding by considering the insights of the entire group.
Right, and the most common way to aggregate these predictions is by majority voting. The class with the most votes from the individual models wins.
So it's like a democratic process for machine learning.
Exactly. And this approach helps smooth out errors and prevent something called overfitting, which is when a model learns the training data too well and doesn't generalize well to new, unseen data.
So bagging helps create a more robust and reliable model by drawing wisdom from the crowd.
Exactly. Now let's move on to boosting, which takes a slightly different approach.
Okay, boosting.
Yeah.
How is that different from bagging?
Well, instead of creating multiple independent models like bagging, does boosting builds a sequence of models where each model tries to correct the mistakes of the previous one.
So it's like having a team of specialists, each focusing on refining a particular aspect of a project?
Yeah, that's a good way to think about it. The first model in the sequence might be pretty basic, but then the next model comes along and focuses on the data points that the first model misclassified.
So it's like each model is learning from the weaknesses of its predecessor.
Exactly. And to do this, boosting algorithms assign weights to the data points.
Weights. What do you mean by that?
So data points that were misclassified by the previous model get higher weights. This means that the next model will pay more attention to those harder to classify examples and try to get them right.
So it's like giving extra credit for solving the tough problems.
Exactly. And this iterative process keeps going with each new model, refining the predictions and boosting the overall accuracy.
Now, when we were researching boosting, we came across an algorithm called AdaBoost. What's so special about that one?
AdaBoost, which stands for adaptive boosting, is kind of a celebrity in the boosting world.
Oh, really? Why is that?
Well, for one, it was the first really successful boosting algorithm designed for binary classification problems, where you're trying to classify something into one of two categories.
So AdaBoost was a pioneer in its field.
Exactly. And it's still widely used today because it's been proven to be really effective. Plus, it even won a prestigious award, the Gödel Prize.
Wow, so AdaBoost isn't just a good algorithm. It's a prize-winning champion.
Precisely. It's a testament to how powerful boosting can be.
So to recap, bagging is like having a bunch of different students studying the same material and then coming together to share their knowledge, while boosting is more like a relay race where each runner passes the baton to the next one, building on the progress made so far.
That's a great summary. And both of these ensemble methods are incredibly valuable tools in the machine learning toolkit. They help us build more accurate, robust, and reliable models.
And it makes you wonder, could we apply these principles of ensemble learning beyond the realm of machine learning?
That's an interesting thought. What if we could use bagging and boosting to improve decision-making processes in other areas of life, like in business or even in our personal lives.
Yeah, instead of just relying on our own limited perspective, maybe we could gather insights from a diverse group of people and iteratively refine our thinking by focusing on the areas where we tend to make mistakes.
It's definitely something to ponder, food for thought for our listeners.
Absolutely. Thanks for joining us on this deep dive into bagging and boosting. We'll catch you next time on AI Talks.
See you then!